So up to this point, we've talked about rational functions of the parent functions of rational functions. We've talked about the y equals a over x, so very simple rational functions. And then we talked a little bit about rational functions and their translations. So there's going to be one more setup that we're going to talk about for today, and that is the form y is equal to ax plus b over cx plus d. And these graphs are also hyperbolas. When you have your rational functions in this form, there's two new pieces of information that is going to be important to know. The first is your vertical asymptote occurs at the x value that makes your denominator equal to 0. Okay? So your vertical asymptote occurs when your x value, at the x value, when your that makes your denominator equal to 0. Your horizontal asymptote is the line y is equal to a over c. So your horizontal asymptote, so horizontal, is the line y is equal to a over c, and your vertical asymptote is the x value that makes your denominator equal to 0. So let's look at example 3, our last example, that deals with your rational functions in this new form. So in example 3, we have the graph y is equal to 6x plus 1 over 2x minus 4. Again, they want us to graph this equation as well as state the domain and range. So step 1 is obviously the same as the other step 1s in the previous two examples. We want to draw the asymptotes. So the first thing we're going to do is we're going to find our vertical asymptote. And our vertical asymptote, if we look above, we have two setups here, or a setup here that looks very similar to the rational function with the form listed above. And our vertical asymptote, if you remember, is the x value that makes our denominator equal to 0. So if I take our denominator, which is 2x minus 4, and set it equal to 0, if I solve this for the denominator, whatever I get from my x value is going to be my vertical asymptote. So I'm going to add 4 to both sides, so I get 2x is equal to 4. Divide both sides by 2, so I get x is equal to 2. So my vertical asymptote is x is equal to 2. My horizontal asymptote now is, of course, the line y is equal to a, which is the value in front of my numerator x, divided by my c value, which is the coefficient in front of my denominator x, which is 2. So if I divide those two numbers, I get y is equal to 3 as my horizontal asymptote. Right off the bat, I'm going to take my highlighter and actually graph these, or plot these vertical and horizontal asymptotes. So vertical asymptote is at x is equal to 2, which is going to be this line. And y is equal to 3, 1, 2, 3. And I should get those two lines as my vertical and horizontal asymptote. At this point, it gets more and more difficult to pick points that work really well with the graph, especially now that you have an x value in the numerator and denominator. So what my suggestion is you're going to kind of go to your new origin, so to speak, your horizontal and vertical asymptote where they meet, and I want you to pick x values a little to the left of that new intersection and a little to the right of that intersection. Because obviously that intersection itself, we know that points cannot exist there because they are asymptotes. So points that I'm going to pick are going to be -1, 0. So I'm going to make sure I'm to the left of that intersection. And then I'm going to pick 3 and 4. Okay, so if I plug -1 in, I'm going to use my calculator. 6 times -1 plus 1 gives me -5. Divided by -1 plugged in, 2 times -1 is -2, minus 4 gives me -6. If I plug that into my calculator, that's going to give me the point 0.83, approximately. If I plug 0 in, 0 works well because 6 times 0 is 0, so I get 1 in my numerator. 2 times 0 is 0, so I get -4. and that's obviously the point negative 0.25. If I plug 3 in, 6 times 3 is 18, plus 1 gives me 19. Divided by 2 times 3 is 6, minus 2 gives me 2. If I crunch that in my calculator, I get a point like 9.5. The last one I have is if I plug in 4. So 4 times 6 is 24, plus 1 is 25. Divided by 2 times 4 is 8, minus 4 is 4. Crunch that in my calculator, that's going to be about 6.25. So if I plot those points, they're not going to necessarily be exact, but they're going to be pretty close. We should see them fall in opposite branches of each other. So if I go from -1, now make sure, because this is an easy way to get stuck, don't start counting from the intersection of your asymptotes. You're always talking, when you're in terms of plotting, you're always going to start from your origin, always. So -1, positive 0.83, which is close to 1, is going to be close to there. 0, negative 0.25 is probably going to be close to there. If I go to 3 now.
If someone on the staff could call down, I'm looking for the